Hi everyone and welcome back to DotNet in Minutes. Today we are talking about something that every backend developer faces sooner or later, building APIs for mobile. At first it sounded the same as building APIs for web apps, right? Same endpoints, same database, same logic. But once you start dealing with mobile clients, everything changes. Performance, authentication, caching, even payload size. So in this episode, we'll break down exactly what's different when your client isn't a browser, but a phone. How mobile clients talk to APIs. Let's start with the basic. When a mobile client call your API, it's usually to the same HTTP request, get, post, put, delete. But the context is very different. Unlike browsers, mobile clients have unstable internet connections, have limited bandwidth and data plans, need faster responses to feel instant. That means your API design must focus on speed, reliability, and same payloads, not just building for correctness. You are building for experience. Optimizing payload size. One of the biggest difference is data size. A web app might handle a 500 kilobytes JSON just fine. A mobile app on 3G, not so much. To optimize payloads, send only what needed. Use DTOs, not entire objects. Implement pagination for list. Support compression like gzip or broadly. Avoid deeply nested JSON structures. Remember, on mobile, even every byte counts. Caching and offline support. Mobile devices go offline all the time. Elevators, airplanes, bad Wi-Fi. That means your API should help clients catch intelligently. You can get e-tags and if modify scenes headers. Include cache control policy in responses. Provide lightweight endpoints for refreshing only changing data. Some apps even offline actions. The user adds data locally and your API processes in once they're back online. Designed for disconnection is the rule, not the exception. Authentication for mobile. Authentication on a mobile brings its own challenges. You can't just rely on cookies or session state like in web apps. Instead, use token-based auth, usually with JWT or auth 2.0. Mobile apps store the token securely in the device keychain or secure storage. Your API must be ready to issue tokens safely, refresh them when they expire, revoke them if stolen. Security and simplicity. That's the balance. Performance and latency. Every millisecond matters on a mobile. That means use CDN for static asset. Reduce number of requests. Batch where possible. Use asynchronous processing. Enable HTTP 2 or gRPC where appropriate. The golden rule. Less round trips equal faster user experience. Error handling and feedback. Mobile users don't read error codes, they feel them. A slow request, a silent failure, that's frustration. Your API must respond consistently and clearly. Always include readable error messages, use proper HTTP codes for 100, 401, 500, return rate hints when it's needed. This helps the mobile app decide when to show error, retry, or go offline mode. Versioning and backward compatibility. Unlike web apps, you can instantly update all mobile clients. All app versions will keep hitting your API for months, even years. That's why versioning is critical. Use versions root like API, v2 users, or custom headers. X minus API minus version. Always maintain backward compatibility as long as possible. Remember, once your mobile API is in production, it's a contract you can break. Monitoring mobile usage. Finally, monitor your API for mobile specific issues. Track which app versions are calling you, which endpoints are slow on mobile, error raised by device type or OS. Tool like Application Insight or Firebase Analytics can help you type backend metrics to client behavior. That's how you close the feedback loop. So, to wrap up, mobile APIs need to be lightweight, fast, and resilient. Handle offline mode and versioning carefully. Log everything and monitor user experience from the backend side. When you design APIs for mobile, you are not just building endpoints, you are building the heartbeat of someone app. Thanks for listening to Dynamic Minutes. See you next episode, guys. Bye bye.